Here are the meters that I would like to use on my analog metered power supply. And they're nice little meters, mirrored scale, and each one is calibrated 0 to 30. The difference is that this is amps and this is volts. This is actually measuring the voltage applied across the terminals on the back. The ammeter, however, is not reading 0 to 30 of anything right now. It's designed to have attached to the back or remotely attached with a set of wires a resistor called a shunt. When 30 amps flows through the shunt resistor, the meter will deflect and indicate 30A. This is the shunt resistor, and it is totally unmarked. You can see it's got these two square metal pads, two small screws. The intention is to carry these two terminals to the back of the meter. And then apply the unknown current through here. Now this meter is marked right under the A. I don't know if you can see that. You see it's marked 75 millivolts. 30 amps flows through here. 75 millivolts is generated across these terminals. And if you look closely, stick a piece of paper under the flat band. You see those little tiny notches? Here and down here's one. Well, there's really two up here. I don't know if you can see how it's notched out. That was probably done to calibrate the value of this shunt resistor. I actually took a little bite out of it a couple different places. In any event, the only thing we know, because this is not marked, is that it produces 75 millivolts when 30 amps passing through this shunt. I would like to use this nicely calibrated 0 to 30 meter to read 0 to 3 amps. So I need to make a shunt resistor. I have some 16 gauge nichrome wire here. Now, I know a little tiny bit of current will flow through the meter, but I don't know how much. In any event, it doesn't matter. I have a diameter versus ohms per foot for nichrome type A and nichrome type C. I don't know what type 60 is. 75 millivolts is 0.075 volts, and since R equals V divided by A, we put V on top, divide it by 3, and I get a resistance in ohms of 0.025 ohms. Number 16 has a resistance of 0.02 ohms per inch. I got that by averaging type A and type C and dividing by 12. If I need a little bit more than an inch, according to this, I need an inch theoretically provides 0.2 ohms. I need 0.25 ohms. I have a piece of nichrome. I'm going to put 3 amps through this section of it. And what I'll do is I'll take these white wires. I will start around very close, and you see I need 3 times that, which I know because my 3 amps of current is causing a 1, say this meter has been there's been decimal points inserted, so this would be 1 amp. Well, it's not 1 amp, it's 3 amps, so we need to go a little wider. There. So we need about that much wire. I cut off a piece of 4-inch long nichrome wire, and I marked it at the 2-inch mark exactly in the middle. Now this stuff's hard to bend and it's hard to cut, so don't use your normal side cutters you use for PC boards. Get a pair of Big Mothers. I'm going to bend it into a hairpin. Now, this meter doesn't have threaded terminals, it has internal threaded terminals. And provided with the meter kit were some attaching screws. Now these are actually M3 threads. So I've taken a little brass standoff and I'll put a washer on it. Actually, I'll put 2 washers on it. There's 2. And I'll slide this in here, and I'll slide the hairpin through here. Okay, so I've got the hairpin, and I've got a sliding terminal on it, and I've connected it to this. This is one piece of wire down to here. I'll take my power supply and I hook it up like this. Power supply is still set to provide 1.5 amps. Okay. So I need to slide apart this little terminal ever so slightly to get a 1.5 amp deflection. Well, I had to lengthen the nichrome wire, but there's the meter reading with 2 amps passing through it. So what this means is that this is about the right length of wire to calibrate this meter. Just a hair less. So what I've done is, without moving this very far, I kept it tight. I bent the loop in like this. There's actually 2 of them, of course. And I've got 2 amps flowing in the power supply. And there you can see, looking at the mirrored scale, 2 amps. I'm going to increase the current to 3 amps. And there we have 3 amps. Loosen this very slightly and spring these together a little bit. Now, I did all the bending off the meter. And I bent it so these were both parallel, well, flat. I don't want to put any undue strain on the meter terminals. This is really stiff wire. Two loops are not touching each other. They're very stiff. What I'm going to do is let it sit for a day or so. And if it still does not need adjusted, I'll cut these off. So now all I have to do is take this piece of plastic off and put a little dot between the 1 and the 0, 2 and 0, and 3 and 0, and it'll be an indication of 3 amps. So I hope you enjoyed this. I'm slowly building up to getting it assembled into a power supply. So if you enjoy this kind of stuff, give me a thumbs up or drop me a comment or come back for the next video. Thank you.